Okay, so for today, your warm-up, you should already have your calculator, journal, and pencil pouch out on your desk. I'm giving you a table of x and y values, and I want you to find the slope 3 different ways. So go back in your notes if you need to. You should definitely be able to find it 2 ways, and then the third way might just need a refresher. So find the slope 3 different ways, and then when you're done, check with your neighbor, see maybe if they have the same ways as you, and then we'll go over it. Alright, the first way that I'm going to find the slope from a table is doing the change of y over the change of x. Okay, so that's one way that you can find the slope. So, looking at the change of y, I'm going to pick these 2 points right here. Okay, and from 4 to 12, I went up 8. That's the change of y. And the change of x, from 0 to 2, I went up 2. Which gives me the slope. 2 goes into 8 4 times, so it should be 4 over 1. So far my slope here is 4 over 1, using the change of y over change of x. Okay, the second way I'm going to find the slope is, I'm going to use those same points again, and I'm going to use the formula y2 minus y1 over x2 minus x1. So the points that I have are 0, 4, and 2, 12. So just to relabel those, this is my x1, y1, x2, y2. Again, if you don't have this method, go ahead and write that down. And I'm going to go ahead and fill out or substitute these numbers in place for the equation. So y2 is 12. Minus the y1 is 4. All over x2 is 2. Minus the x1 is 0. So I end up having 12 minus 4 is 8. Over 2 minus 0 is 2, which simplifies to 4 over 1. So far I have 2 methods that give me the slope of 4 over 1. The third method I'm going to use is my calculator, because we know how to enter this table into the calculator. So, to refresh your memory, I'm going to go to Stat, Edit, which is 1. Let's go ahead and enter this in. So I need to clear my L2, so highlight L2, push clear, enter. Highlight your L1, push clear and enter. And I'm going to go ahead and enter in the table for this question. So I have 0, enter, 2, enter, 3, enter, 7, enter for the x values. 4, enter, 12, enter, 16, enter, and 32, enter for the y values. What are my next steps here? Okay, I push Stat again. Now I go over to the right one for Calc. Which one do I go to? LinReg 4, push enter. Go all the way down to calculate, and this will give me my slope. Remember, A is the same thing as your slope, so my slope here is 4. So there are 3 different ways. You might have thought of a different way, and hopefully you got that same answer, but those are 3 ways right there to find the slope. So now looking at my problem with this slope, is this proportional? Okay, you should have said no. And is it a direct variation? No, both of these are no. Why is this not proportional or a direct variation? Because it seems like all the slopes are the same. There's a constant of variation there, or a constant rate of change, or constant slope. But why are these not proportional and a direct variation? Okay, if I pull my calculator back out, and I look at that stat information, LinReg, what's the y-intercept here? The b is 4. Okay, if I look at my table, when x is 0, that's my y-intercept. So these are not proportional and not a direct variation because the y-intercept is not 0. Okay, remember it has to have a constant rate of change or a constant of variation, and it has to go through the origin. The y-intercept has to be 0. Okay, so we're just going to recap briefly about direct variation. So on the next page in your journal, go ahead and label that direct variation recap. Today is October 6, 2016. And go ahead and head the paper along with the page number in the top right. Fill out your table of contents, and when everyone's ready, we will begin. Okay, just a recap from yesterday. Okay, what we know is if something varies directly, it's the same thing as varying proportionally. And go ahead and put a big highlighter box around that. Varying directly is the same thing as varying proportionally. Proportional and direct variation mean the same exact thing. Now, I want you and your partner to list some things right underneath that you remember about direct variation or proportional. What do they have to have? Go ahead and take a couple minutes to do that, and then when everyone's ready, maybe let's say 3 minutes. Write down as much as you can, and then we'll go over what I have. Okay, so with your partner, hopefully you came up with some things that I did as well. You might have some more, you might have less. Just make sure you have these things written down. Okay, when it comes to varying directly, okay, or direct variation and proportional, that means that all of the equations are in y equals kx. Now we use that formula again when we vary directly or direct variation. Or proportional, it would just be y equals mx. Okay, but no matter what, there cannot be a b or a y-intercept. So I'm going to highlight that. There's no y-intercept. Do you want to write that down as well? No y-intercept. That means it's proportional or a direct variation. If you're looking at a table, okay, what should it have on the table for you to determine if it's proportional or direct variation? It should have 0, 0 as a point. Okay, because that shows it goes through the origin. And when I find the y over x to find the k, that has to be the same for all points. Okay, so the constant of variation is the same for all. Again, the constant of variation is our k, or the slope. It's the same exact thing. Has to be the same for all the points. And because the constant of variation is the same, that means it makes a straight line. Okay, so whenever I graph this thing, it goes through the origin, again, which is 0, 0, and forms a straight line because the constant rate of change is the same. Okay, so let's just recap briefly. Let's make a t-chart of something that's not a direct variation versus a direct variation. So I'm going to go make a t-chart, not a direct variation on one side versus a direct variation on the other. Okay, if I want to give an example of an equation that's not a direct variation, remember your direct variation snowball fight yesterday. Okay, not a direct variation means it has y equals, let's say, mx, but this time it has a y-intercept, because that means it doesn't go through the origin. Okay, so because it has a b, that means it's not a direct variation. It's not proportional. Okay, a direct variation equation would be y is equal to negative 10x. Okay, that is a direct variation because, again, it goes through the origin because there's no b there. If I drew a graph of something that's not a direct variation, for instance this one, okay, it's a positive slope, so it's going up from left to right, and the y-intercept is 5. So let's say it looks something like this. That would be considered not a direct variation. It does not go through the origin. Okay, over here I have my graph. It's a negative slope because it's negative 10, but this time it goes through the origin because the y-intercept here is 0. And then remember how to find it from a table as well. If I write down this table, here's my xy. Go ahead and copy this down. Let's say 2, 4, 10, and 15 for the x values, and 20, 40, 100, and 140 for the y values. Okay, again, remember we have to use the formula to find the constant y over x. So if I do the first point, y over x, I have 20 over 2, which is 10. I have to do every single point. Y over x, 40 over 4, which is 10. 100 over 10, which is 10. So far it looks like it's a direct variation, but then I look at the last one, y, 140 over x, 15. That ends up giving me, if I look at my calculator, 140 over 15 is 9.33. So because that last one does not have a constant of variation of 10, that would mean that it's not a direct variation. So this would be not the same k. Highlight that. Every point has to have the same constant of variation. An example of a table that is a direct variation. Again, we always look for the 0, 0 as well, but most of the time it's not listed. So 5 and 15, 9 and 27, and 15 and 45. Again, I use the formula y over x to find the k. So 15 over 5 is 3. Y over x, 27 over 9 is 3. Y over x, 45 over 15 is 3. So to find the constant, since all of these are the same, that would be considered a direct variation. Okay, so that's briefly just a recap. There's only one more thing I want to talk about before you get your assignment, so you'll have plenty of time in class to work on the assignment today, is when I give you this equation, you're going to have to convert it to y equals mx plus b to determine if it's a direct variation or not. So let's say 3x plus 2y equals 12. And again, I want to convert this to figure out if it's a direct variation or not, because again, I can't plug this in my calculator to see if it goes through the origin. So draw your line down the equal sign, put y equals on the left, mx plus b on the right. So to get y by itself on the left, let's get rid of this 3x. So I'm going to take away 3x on both sides, which leaves me with 2y equals negative 3x plus 12. Okay, from here I want y by itself, so right now it's 2 times y, so I'm going to divide by that 2 on the left. Whatever I do to one side I have to do to the other side, so I divide the whole right side by 2. And now I rewrite what I have. I have y is equal to negative 3 over 2x and then 12 over 2, which again 12 over 2 is 6. So I can go ahead and write it that way, or 6 over 1. So this is the equation. This equation is the same thing as what we started with, it's just another form. So I need to determine, is this equation, which is the same exact thing, is it a direct variation? Okay, you should have said not a direct variation. Why is this not a direct variation? What makes this not a direct variation? Okay, this 6 represents that is where it crosses over the y-axis. If I actually plug this into my equation, or in my graph, everyone get your calculator out. Let's go to y equals. And let's plug this in. Okay, now when you plug in a fraction, I'm going to put that in parentheses, so use your parentheses button. Remember, that's the one right above the 8. So parentheses, I'm going to put negative 3 divided by 2 and the parentheses. Put your x. Remember, x is right by the alpha. And then I'm going to put plus 6. Should look like this. Okay, now when I graph it, that's going to tell me if it's proportional or direct variation. Where does it cross over that y-axis? Okay, it crosses over at the 6. It's not proportional. It doesn't go through the origin. If it was shifted down 6 units, then it would be, but it's not. So that's why this makes it not a direct variation. Okay, so that's just a good recap of everything that we talked about yesterday. Keep those notes out on your desk. What you're going to be given is your homework assignment, so we'll have someone hand that out. When you get it, put your name at the top, class period, and the date. And you're also going to need a separate piece of paper to show your work, so go ahead and get that out. Okay, put your name at the top. 3-2. Today is the 6th of October. And your period Friday. You can go ahead and fold that in half. And draw your line down the middle. So looking at the assignment, okay, you're doing this independently. 1 through 4 says, determine whether each equation represents a direct variation. If it does, find the constant of variation. So there's 2 parts if it is a direct variation. So they give you an equation. So let's do the first one together. Go ahead and recopy that down. 3y plus 2 equals 2x. Now again, I want to put this into slope-intercept form to determine if it goes through the origin or not. So I'm going to write y equals mx plus b at the top. And if you want to highlight that to make it stand out, that's fine. So what I'm going to have to do is, I need y by itself over here, so let's get rid of this plus 2. To get rid of the plus 2, I'm going to subtract 2 on both sides, which leaves me with 3y is equal to 2x minus 2. Again, you must show me your work for every problem. From here, again, y needs to be by itself, so I have to divide by 3 on both sides. So I end up having y is equal to 2/3 x minus 2/3. I'm going to circle that. Now the question's asking me, determine whether each equation represents a direct variation. Okay, so if I look at this equation, is this a direct variation? It has a constant rate of change, but what's the y-intercept? The y-intercept here is -2/3. Does that go through the origin? No, it does not. So I'm going to write next to number 1 that this is not a direct variation. I want you to write out the whole thing. Now, if it was direct variation, I would have to write down direct variation, and then it would say, okay, now find the constant of variation. So looking at this equation, what would be the constant of variation? Remember, the constant of variation is the same thing as the slope. So in this case, the constant of variation would be 2/3. Okay, so you're going to do that for 1 through 4. If you look at 5 and 6, this is similar to the word problems that we did, not in class today, but yesterday. It says y varies directly with x. Write a direct variation equation that relates x and y. So you're going to know how to write the equation. 7 and 8. Okay, write an equation for the direct variation, so you have to find the k to write the equation. And 9 through 12 are very similar to what you did in your notes yesterday. So you're working on this independently. And then maybe the last couple minutes of class, you can ask your neighbor for any help before you leave for the day. And this will be due tomorrow, so make sure you have that fully completed. I would also expect a quiz tomorrow over 3-1, finding a slope from a graph, table, and coordinates, and 3-2, direct variation. So expect a quiz tomorrow. Have a great day.